G'day guys, Mr. Warren here. I'm looking at the first test that you guys have done as part of your preparation for your interview tests that start appearing in, let's see, when you guys are in grade 12, that would be 2021 I think. So this morning you took your first test that was looking at some stuff that you've covered over in geology and biology and the current content of chemistry. And you might be thinking, oh, I didn't do too well on that, so how do I get better at taking tests? Or perhaps you're going, well, okay, I did okay, but maybe things could have been better, or even you're feeling pretty good and you'd just like to know how you went. So I've got your test here. I had not seen it before today, so I'm not 100% on the content in it either. However, what I will do for this is go through a series of videos. I'll do one for each section just to break it down a little bit about how I would personally tackle each of these sort of questions, to show you what sort of things we would be expecting to see for marks and the thinking that I go through in order to address it. First up, let's have a look at a couple of things that we should do for doing a test. So the first one is perusal time. Now, perusal time is not just, oh yeah, I have a read through and see what makes sense, what doesn't make sense, and what I've got to start asking. It's a time for you to actually work out a strategy of what you're going to attempt to answer. Now, depending on the type of test, you might be able to write in the exam booklet while you're doing perusal time. You might not be. It does depend a lot on the exam, but what I would do when I'm doing perusal time is I'm looking for, well, what am I going to do first? Okay, what can I look at there and go, yep, I know that, I can smash that out straight away, so that I'm off to a good start. Then I started looking at it, okay, well, what else am I going to need to think about a little bit, and what might take me a bit of time to actually work through, because it looks like a pretty detailed question. And one of the things you'll notice, if I flip over to any of the pages here, like this question here, we see that, oh yeah, a bunch of content, then we've got, let me just lift it, so let me lift that up a bit more. So question 10 here, we see, oh yeah, a bit of reading here to do, then we get down to the actual question part, we see, oh, it's worth 1 mark. A 1 mark question is just going to be multiple choice or a couple of words at most. It's not going to be particularly a lot of information for me to do. It's almost the equivalent of a C standard. But if we look up here at question 9, and we go, okay, we've got similar amount of reading to as here. We've got a diagram as well. While down here we had a picture. But now if I have a look at this, I've got a big empty space I'm going to be writing in, and I've got 3 marks. So that tells me that should take me a little bit longer, and it should require me to think a little bit more about it. Okay, so when I'm doing my perusal, think about what I'm going to do first, what's going to take some time, because remember, you've only got 60 minutes to do a bit of test like this, and you need to be keeping on pace, because you might spend 5 minutes more making one question really good, but that 5 minutes could have got you 5 other questions done, which would have got you more marks. So spending 5 more minutes on a 3-mark question might be the difference between 2 or 3 marks, but those 5 minutes spent on 5 1-minute mark questions would be the difference between 0 marks and 5 marks, and it's a lot better to get those 5 marks than it is to get just 1 more mark on another question. So perusal time, think about what you're going to do first, and have a bit of a reflection about how much time you're going to spend on things. Question 2, the second thing I always like to do is, if I read a question, I give myself a time limit to answer it. So time limit to answer. Okay, and for example, I will generally go, if I can't do it in 30 seconds, I skip it. I don't mean, can I finish the question in 30 seconds? I mean, if I can't start answering that in 30 seconds because I don't know it, I skip it straight away. And sometimes it might even be less, depending on the type of exam it is. Like if it's multiple choice stuff, where your answer is there in front of you, I'll give it 10 seconds. Okay, so like 30 seconds might be a short answer. I might give myself about 10 seconds for multiple choice. Now, I won't necessarily leave them entirely blank on my first pass through. I might go, oh, okay, for this multiple choice one, oh, this one's definitely wrong, so let's cross that out. This one might be right, so maybe that's right. Oh, but that one could be right as well, so I'll just put a little question mark next to each of them, and then I'll come back to it. I'm not 100% certain. I want to let my brain chew it over a bit and see what else is in the rest of the booklet, because there might be some clues later on that tells me about it. But I'm going to just not worry about putting it in straight away. I could spend a minute there seeing, oh, okay, well, what about this or this and this, and thinking it through. But your brain's going to do that anyway, even if you're not consciously thinking about it. So it is generally best to go, I know this answer, good. Not 100% on this answer. I'll put a couple of marks here and I'll move on. For short answers, similar sort of things, you should be able to have a bit of an idea of what you want to talk about, so that you can actually respond promptly to these questions. If you can't, skip it, come back to it. Do not waste a lot of time at the start sitting there going, ugh, because, excuse me, there might be something later on down that exam that is really easy for you to answer, that you could spend a couple of minutes getting a much better mark on than puzzling over this thing right at the very start. Okay, so give yourself a time limit to answer on your first pass through. Okay, get all the easy stuff done out of the way. It doesn't matter what order you do it in. If you happen to have an exam booklet that you have to answer in, unlike this one where we can see that the answers are going to be put into the spaces inside of it, it'll be very common down the track where you'll get an exam booklet like this. There won't be any spaces here for you to answer. Instead, you'll answer on separate sheet paper. And so, with that sort of thing, it's partly expected that you answer it however you want. You're going to do question 1, and then question 10, and then go back to question 7. You knock yourself out. It's not a problem. You just got to label it. Okay, so don't stress about how doing it. I've got to do question 1, then question 2, then question 3. Okay. Third, now, each question requires you to read the language, so you should be looking for, or look for, the verb. Look for the action. What is the question asking you to do? So if we go to here, like we see we need to identify. So to identify something means to name it, to find out one particular thing. Now, I could write a response here in a sentence. So it says identify one third order or tertiary consumer. I might say an example of a third order consumer is blah. Now, that's great in English, but that just took 5 times as long to write as if someone just wrote blah, whatever the answer is. Here's the thing, this is a half-mark question. Okay? That means that that person who just wrote one single word for the name of an organism got just as many marks as that person who spent 5 times as long getting a full sentence out. It doesn't help. Okay? And that time is precious to you. Up here we've got a 1-mark question. Identify a carnivore, give one specific example. Okay? So carnivore, I might put here carnivore equals whatever. Example, I might put example equals whatever. Okay? Short, straightforward. I know that the person should be able to read it and understand it. You could even go, well, carnivore, I'll write that person on the carnivore, I'll write something under example just to link it up. Okay? You could go again, but here's the thing, it's about being efficient in how you answer. Okay? And so that looking for the verb leads to efficiency. Okay, now I think those are 3 pretty good things to get yourself started. Now, some other common things. 4, nothing blank. 5, use other questions. If you get stuck. I know personally that there have been several exams where I've been stuck on a question and I've gone and looked down later on in the exam and I've seen, oh, that's going to help me out for that. So now that helps you actually answer that question. Okay? So treat the exam as an entirety. You can use stuff later on to clue you in for stuff earlier on in the exam, and vice versa. Each question should be answered individually. However, you can always, try to find extra information down the track. And 6, reread. Okay, if you're stuck with something, or generally with certain more complicated questions, reread the question. Make sure you understand that. Don't sit there and go, oh yeah, I've read it once, I understand it, and off you go, because commonly you don't. And I've seen this with you guys. I've sit there and gone, oh okay, they've misinterpreted part of this question when a rereading of it would have fixed it up. Okay, so let's get a look in this. We're going to do section 1 first, part A, and we have Earth Sciences. So, question 1 here. We've got instruction to look at the diagram, and we can see how we have some labelling of plates. We have some arrows which look like they are main movement directions. We have different types of dots. We can see here we've got some close dots, while down here we've got some more jagged ones, and here it's kind of an arrow with the directions. And we can see here we've got a key for collision boundaries, something where we don't know the movement. Here between Eurasian and whatever that is in China, that one looks to be unknown. Spreading boundaries, a lot of that through the oceans there, and transform boundaries, which we should remember. There's a very big one over there. So if we have a look through this first part of the question, we see the verb describe. So we need to give it a description of something. So we need to give a bit of information, a statement defining what it is, and we want to look at the relationship between plate boundaries and where earthquakes and volcanoes occur. We want to use the map to help illustrate our answer. Okay. Now, what we're talking about here is that we want to refer to a part of the map to help give reasoning for this. Okay. So we want to make sure we do use that map. Okay, so what is the relationship between plate boundaries and earthquakes? We should recall that wherever or that earthquakes mostly occur at plate boundaries. Volcanoes mostly occur at, now we can use a bit of specific language, divergent, and let's see what type of convergent. It's not CCs, because CCs cause mountains, as we should recall, and it's not OOs, they mostly cause trenches, and here we've got the Marianas Trench, where the Pacific and the Philippine plate are coming together. There are some volcanoes near it, however, that's not as prevalent, and with CO, now don't use acronyms until you've defined them. So the first time we use an acronym, we should always make sure we do it properly. So continental, oceanic convergence. Now, this here to me is about 1 to 1.5 points worth of information. You've told what the relationship is. Now we need to use the map to help explain it. Note, it's not saying explain the relationship. It is just asking us to describe the relationship, and we've done that there. Now, if we went and said that, well, volcanoes occur at divergent boundaries because the crust is splitting apart and new lava is coming up, which is what a volcano is defined as. Now we're into explaining, and this is only asking for describing. Now, I'm not looking at the answer key, I don't have that with me. I'm just going based off what I would see here. Now, if you're a fast writer, include that extra information. But if you're not, you might want to not do that. Okay, so at divergent boundaries, the spreading crust lets up new magma / lava at CO, and this is where our definition is good. And since I've defined that, let's go back up here and put a CO at CO boundaries. Let's see what we want to say there. So remember when we have the continental boundary going in underneath, so the oceanic boundary going in under continental boundary. We want to use that subject-specific language. Let's see, subduction, that was it. The subduction leads, don't have to explain it fully, to volcanism. Okay, on the map, so we want to activate that last verb. On the map, a divergent boundary is at the X, and a CO boundary at circle. Both have volcanoes. Okay, so the one I'm really familiar with is here down where the Nazca plate crashes into the South American plate. So that's going to be an area of volcanism, and this is all this divergent boundary. So let's put an X there. Okay. We want to identify a region of high volcano activity on the previous map by shading it in. Discuss what would happen in the local area if a large volcano. So two reasons we need to identify, and the way we're going to identify is by shading it. So there's our verbs there. We want to discuss what would happen to the local area. Okay, so one of the big things, so this one is about prior knowledge. You have to know where volcanoes mostly are. Remember, we did cover that there is a lot of volcanoes up through New Zealand, through the Philippines, through Southeast Asia, Indonesia, up through Japan, and then down through here. So, I mean, there's all these volcanoes right above the north of us. Let's do a volcano in New Zealand. So let's say that here, where we have a CO collision, there's a volcano. So New Zealand, let's specifically say it, has volcanoes. Now we don't have to explain why we know it. There's nothing about here about explaining how we know that they're. And let's say we're shown by okay, due to large populations. An eruption would cause damage by destruction of buildings and population centres. It would also set off earthquakes and possible avalanches. Okay, so we've identified the region. We've discussed what would happen to the local area. Well, we've said, well, around that local area, there would be destruction of buildings, there would be population centres. We could also set off earthquakes and possible avalanche if there are mountains, and New Zealand's pretty mountainous, so that's a fairly good bet there. Okay, but all we've done is we've kept it local. Okay, I haven't said, oh yeah, volcano gets up here, and then bang, we've got a tornado down here in Australia. Okay, that would not be local. Let's have a look on to the next page. Okay, propose a possible reason why volcanoes are not common at transform plate boundaries. So let's think about what's the cause. So proposing in this case and possible is the important, like this is what we're saying here is we just need to sort of provide one, we need to give a thing. The possible is another important word here, because possible is telling us that it has to be plausible, it has to be realistic. For example, if you said that, oh yeah, there's no volcanoes at transform plate boundaries because transform plate boundaries turn into transformers. So that's not possible at all, it's not plausible, you haven't really explained anything. So we need to explain a little bit, or at least link how transform boundaries work and compare it to how volcanoes are actually created. Okay, so how do transform boundaries work? Transform boundaries work by plates sliding across each other. There is no subduction, while volcanoes require that subduction or the splitting apart of crust. And since transform boundaries don't slide apart and they don't come together, they only move past each other, we don't get those triggers. So let's save that. So volcanoes occur from divergent splitting boundaries. The stapling on this is a little bit inconvenient, I imagine. Boundaries letting up lava. Or CO, remember we established that acronym before, CO boundaries having subduction. Transform boundaries slide past each other and rarely, note I'm using the word rarely because this is not common, not impossible, so it's not common. So let's use a nice little synonym there. So, and rarely involve lava. Okay, this might actually be a little bit long with the fact that we've talked about divergent CO boundaries. We could probably get away with just transform boundaries slide past each other and rarely involve lava, but I think some of the information might be needed to achieve a full 1 mark. Okay, question 2. Volcanoes of Hawaii are located towards the center of the Pacific plate rather than its plate boundary. Explain how tectonic processes form volcanoes such as the ones found in Hawaii. Okay, so we don't have a lot of space here. We've only got 1 mark. We are looking for an explain type thing though. So this one's going to be a little bit tricky. We could state that Hawaii is caused by hotspot volcanism. Okay, we've given the reason that we learnt about in class. Now what we want to add on to the end of it is, well, what is hotspot volcanism? So this is when the mantle is super hot and melts through the crust. Okay, nice and simple. We've given an explanation. We don't need to keep it particularly long. Okay. It's only a 1 point question. So even though it's an explain verb, because it's only 1 point, we don't need to go into a massive amount of detail. They've only given us 2 lines. So if you try to, cram 4 lines into there, you're going to have a bit of a problem. Okay, explain why some of the Hawaiian volcanoes are now extinct or dormant. So again, another explanation. We need to give a reason why. So the hotspot, again, this is mostly linked to stuff that we did in class. Hotspot is fixed, and the plate moves over, cutting off the source of magma. Source of magma. Okay, done. Alright, let's go to question 3. Question 3, a geologist receives data from 2 seismographs located A and B below. We can see A and B here are 2 seismographs, but he's unsure whether the epicenter of where the epicenter of the earthquake is located. We can see here that these rings from the seismograph have 2 points. Using the diagram, evaluate which location on the map is most likely to be the source of the earthquake. Okay, so it's going to be location 1 or location 2. So remember that things spread out evenly, and we looked at we did those activities involving difference of time, and so we're looking at, well, which ones are these? So let's go to the diagram and see what else, because it says use the diagram. We need to evaluate, okay, which source is most be likely. So evaluate means we need to make a decision, and then we need to make a reasoning for our decision. So if we have a look on this information, we can see, I reckon these white things are rivers, because that's probably some ocean. They would have some land. I don't believe we're seeing any plate boundaries down here. However, we do have this fault line light up the top. Now, a fault line, remember, is that a place where there is a significant amount of earthquakes, or where, excuse me, where two plates are interacting with each other, like the San Andreas fault, where we have that transform plate boundary going on. So let's start off with that first part of the evaluation to make a statement. So let's go. Point 1 seems the most likely. See how we've got here the most likely? So let's use that same language. Most likely. We don't need to say the source of the earthquakes, because again, a little bit extra time. We only need to just use that one little phrase they've got there. Now, why did we choose that? Okay, A and B can't be it. A and B are the seismographs. It has to be 1 or 2, because that's where the seismograph waves are overlapping. But 1 is closer to the fault line. Okay, so to me, that an earthquake is going to happen close to the fault line, not so much away from the fault line. So as long as there's nothing wrong with this diagram, then I'm going to say it's going to be point 1. This is because, and here I'm using evaluative statements, I'm giving that justification for why I've said this is true. This is because there is a fault line closer to point 1 than 2. Okay. And to continue on with that, because this is a 3-mark question, this is not sufficient to me in order to achieve all 3 marks. Okay. We need to explain why the fault line being close to 1 is an important thing compared to the distance it is from 2. So, point 1 seems to be the most likely. Sorry, very tired this week. This is because there's a fault line closer to point 1 than to point 2. A fault line is a plate boundary interaction, and probably has tension built up, which is released as an earthquake. That seems a bit more reasonable. Sorry, my text was out of thing, but you heard me say it as I wrote it. So now we've gone, we've identified the point that we think is most likely. It looks to be the correct point to me. That's like a mark there. This is because there's a fault line closer to point 1 than to point 2. We've given a basic evaluative statement, a fault line, and now we've explained why that reasoning is important here by going, well, the fault line is a part of the plate boundary interaction, and probably the tension built up, which is released as the earthquake. Okay, let's have a question 4. Identify which of the statements below are evidence for the theory of plate tectonics by circling those that are correct. So first off, we're going to circle some stuff, and I want to draw your attention to the word those. That means there's more than one. So that doesn't mean you only circle one of these things. You can circle more than one of those things, depending on how many you think are right. Okay. Now, nothing here is saying that it had to be modern evidence or ancient evidence, so we don't have to worry about time. What we want to look at is with plate tectonics, so stuff involving the Earth is a big clue there. Now, straight off the bat, if we look through this, studying the evolution of fish, that has nothing to do with the Earth's ocean, the Earth's floor. Okay, yes, we would find fossils of those that would give us information about, where things were connected. However, the actual changing of fish doesn't tell us anything about how the Earth moves. So we can say that that is definitely wrong straight away. Okay, so let's have a look at the other stuff here. Magnetic banding on the seafloors. Now that's something we learned about in class. Remember that when a new lava is set, depending on the strength and direction of the magnetic field, it will have a particular magnetic banding. So that's going to be a right one. Similar fossil types between South America and Africa. Well, remember that's what Wegener used to figure out, to propose the idea of continental drift. So yep, that's right. Satellite imagery of the ocean floors. We did sonar imaging of the ocean floors, and we talked about how satellites can image the continents, but we personally did not talk about satellite imagery of the ocean floors at all. However, whether we image the ocean floor using sonar or we image the whole floor using satellite, just because we haven't covered it doesn't necessarily mean it's not a possible way of evidence. So for this one, I personally would say yes, okay? Because it's asking which of the statements below are evidence. It doesn't necessarily mean, well, what's evidence you've covered about in class. Okay? It could be that, well, they're asking you for to reason these things out, and so I would say that this is definitely going to be one as well. Okay. Question 5, provide all answers on the diagram below. Sketch the convection currents present in the mantle. So convection current, so we want to sketch it, we want to know where the mantle is, okay, and we want to know, well, what on earth is a convection current. So remember, a convection current is the rising, drifting out due to pressure from the upswelling, the cooling, which then allows it to fall before the cyclic pattern continues. So we want to sketch a current on here. So the question is, where does it come up? And we can see here we've got these arrows as the plates are dragged by a current, which give you a bit of an idea. So if we take that there and we go, oh yeah, well it's going to go that way, that way, that way, hit that, get forced down, and then probably continue as it cools. However, up here would end up with things rising in order to drive that. Okay, so nice easy convection current. Identify the location of the two types of plate boundaries divert and state their name. So we were identifying. So we just need to convey something. We do need to state their name. So we're going to have a single word to go for that. And there are two types. Okay, the fact that there are two types tells us there must be two different types of plate boundary. And we should be able to see here, okay, well, hey, look, there's two plate boundaries, they're touching each other here. And we know that that is a divergent, sorry, not divergent, it is a convergent. Probably CO, since that's subducting underneath. Now, if you went and said, oh yeah, here's another convergent. Well, yes, there is another convergent there, but it is not a separate type. So you need to find a separate type. And we should be able to see, oh, the separate type is here, and it is divergent. Okay, now that's where I'm going to end this video, finishing off the Earth science ones. We will do another video for the other two ones shortly. For this last question here, this is 3 marks. This is a really easy, quick 3-mark question. Sketch the convection current. You need to know what a convection current is. You need to know where the mantle is. You just need to be able to draw it in there, and we saw, great, that'd be about a mark. 2 types of plate boundaries, recognizing where they are, that would probably be another mark, or getting one and the name correct, getting the other and the name correct. We don't need to explain anything about divergent boundaries, don't need to explain anything about convection currents. We just needed for this to either sketch where it is, or identify the 2 types and state their name. Alright, so be on the lookout for those cognitive verbs so that you can go through and go, all right, well, this is what I'm actually trying to do in this question. Okay, so check in the next video to see what the answers. I believe next up is chemistry or biology. Next up is chemistry, and then biology after that. Thanks, guys.